Hello everyone, welcome to the next lecture, Setting Altitude, Overlap and Ground Resolution. When planning a drone survey mission, three key parameters directly affect the quality and accuracy of the final map or 3D model. These parameters are flight altitude, image overlap and ground resolution. Understanding how to properly set these values ensures that your drone captures clear images with enough detail for accurate mapping. Let's begin with flight altitude. Flight altitude refers to how high the drone flies above the ground during the survey mission. The altitude you choose affects both the area coverage and the level of detail in the captured images. Flying at a higher altitude allows the drone to capture a larger area in less time because each image captures a wider section of the ground. However, this also reduces image detail. Flying at a lower altitude increases image detail because the camera is closer to the ground, but it requires more flight lines and more images to cover the same area. Surveyors usually choose an altitude that balances coverage, efficiency, and image detail. Now let's talk about image overlap. Image overlap is essential for photogrammetry because it ensures that multiple images contain the same features from different perspectives. This allows software to accurately reconstruct the terrain or objects being surveyed. There are two types of overlap used in drone surveys. The first is front overlap, which is the overlap between images taken along the direction of light. The second is a side overlap, which is the overlap between images captured from adjacent flight paths. Typical mapping missions use around 70 to 80% front overlap and 60 to 70% side overlap. However, overlap generally improves the reliability of the photogrammetry process, especially in areas with complex terrain or structures. Now let's discuss ground resolution, also known as ground sampling distance or GSD. Ground resolution describes the actual size of the area on the ground represented by each pixel in the image. For example, if a drone survey has a GSD of 5 centimeters, each pixel in the image represents 5 centimeters on the ground. A smaller GSD value means higher detail, which is important for projects requiring precise measurements. Ground resolution is influenced mainly by flight altitude and camera sensor quality. Flying lower usually produces a smaller GST and therefore more detailed imagery. However, smaller GST values also mean more images and longer processing times, so it is important to choose a resolution that matches the project requirements. Professional drone surveyors carefully adjust altitude, overlap, and ground resolution to ensure that their missions produce reliable and accurate data. By setting these parameters correctly, you can capture aerial imagery that is suitable for generating orthomosaic maps, terrain models, and detailed survey measurements. In the next lecture, we will explore another critical concept in professional drone surveying, ground control points, often called GCPs, and how they help improve the accuracy of drone maps. Thank you.